Hi, in this session we will take a look at how we can create a Docker image using JDK8, and then we will try to run a simple program into that Docker image. My name is Huram Hanif and I'm solution architect with Nano Integration Services, and we specialize in creating Java native applications and migrating legacy enterprise applications to the cloud. So this in this session, although we are just discussing a very basic concept of creating a Docker with JDK8 and then some very simple program, but this can be a base for doing it on a large scale when you are especially when you are re-architecturing your application and moving from monolithic application into more microservices application. But we will go into that detail a little bit later in this session, and if you are not interested in that kind of discussion, then you can skip that part. Okay, so these are the basic steps what we will do. So let's talk about that one. We'll need to download and configure Docker, Docker desktop version, and the Docker CLI so that we can execute the command. Then we need to create a Docker file which contains a reference image of JDK8. So that Docker file will contain that information for that image and some other configuration which will be related to the work we are doing in this session. We also need to create the packages, which are basically folders, and then those are called packages in Java, and they create the actual Java file which will contain our code which we are trying to run into this program. So if you are not familiar with Java already, don't worry about that. I will try to explain it, and if you will simply use my code which I will make available with this session, then you should be able to run that one. And that's the beauty of this using JDK with the Docker, that even you don't have to worry about setting all that environment variables and doing all those steps by yourself. Docker will take care of about that stuff for you. Okay, once you will have that, I will show you that structure, the file structure, and we will see how that Docker file looks like. We'll talk about that, and then the next step will be to build the image using that project name. Once we have that image, then we will run that image and see if our intended output will be available. Okay, so now let's first go to that file system and see if how our structure is for that particular project. So I have created a Docker Java package or the folder, and I have put my code into that one. Please feel free to rename it whatever you like to do, and I'm using the package in the Java. If you don't want to use the packages, even you can use that main.java directly under this folder, bypassing all that packages. It's your call, and I will show you how to do that as well. We'll have a look into main.java shortly, and this is the Docker file. So while you are in the command line or the terminal in my case, then you want to make sure that you are basically in that folders. An easy way to do that is simply right click that and click new terminal tab at folder, so you don't have to enter all that path. Okay, now we have opened the terminal, but before we actually try to create the image, what I want to do is to show you the actual code. So I'm using that code editor ID. You can use whatever you like, but because this is a very simple Java file, first line contains the package. All the Java folks should be very much familiar with this package naming convention, and if you are new to Java, simply try to understand this from a perspective that you want to organize your files into different folders, so that you can logically have them grouped into different folders. Then we need some imports so that we can use the classes which JDK provided us. And then this is our class. You can rename it if you want to, but if you rename this class, you need to make a change in Dockerfile. I will show you shortly. Then the next is we have the main folder over here. This is the syntax for the main folder. You can copy paste like as is. There is nothing special. You can get a tons of documentation on that one, so I probably would like to skip that one over here. The next thing is that we are creating a list of integer, and then we are using a for loop. We are adding the values into that list, and you can see that this is an integer variable which is a primitive type, whereas this integer is a class. So this is called the autoboxing, when we are actually moving the values from primitive types to its equivalent classes. And as we can see that this integer is defined into the lang, but there is no import for the primitive, so very basic concept. And then in the next one, what we are using an iterator. This is a very traditional way of doing things, but Java 8 has make it much more easier. And so it is basically going through each element over here, getting the element into that integer, and then simply putting that iterator value is the I value, which is the value in that integer class. Okay, once we have that, now this thing is doing the exact same thing what's happening over here, but this is the new way of doing things. So my consumer is a class which implements the consumer interface, and consumer interface is probably something generic defined over there, and whatever you create over here in integer, consumer will simply take it and pass it to the accept method. And now you are creating an object over here for that and passing that mylist or for each, which is on your function in JDK8, and you're passing that action. So action on the iteration, when internal iteration will be happening, it's calling the accept and passing the current value to that one. So we should see the basically, other than this text, we should see the same value 0 to 9. So that's basically very simple class. What's happening over here. Now let's move to the Docker file. So if you are already familiar with Docker, you can see that the first thing, basically what we are, the directive is that use the OpenJDK version 8. Now if the Docker has already cached version, the image is in the local cache, it will use that one. If not, then it will try to pull that from the Docker docker.com, and then at that point this your sign in will be comes handy. If not, then there will be an issue with that. So as we know that once we are working in Docker, there's basically a Linux variant running on your machine. So this copy all the contents from here into the user source my app, that's basically happening inside of that Docker container, and it's not happening on your local machine. So if you'll try to find those folders, you might not be able to do so. So that's, I will explain it a bit later. Once we will run this example, then we'll go back to the drawing board and I will try to explain it. Next command is the run javac, and then there comes the package name and the main.java. So basically this is the compilation of simple this Java class into this corresponding the compiled version, which is a class path binary code. And then the next step is that run that command java, and this is the package name and the main, which will invoke the main function internally. So at this point JRE will execute and run this program. So this is the compilation version and this is the run version. Okay, so this is the Docker file, and yeah, let's move back to the terminal and try to see. So ls minus l, we can see that this is Docker file we were just seeing from that code ID, and then those are the packages which we already saw over there. So now to build that Docker image, what we need to do is we'll need to execute the command docker build -t, and then this is the JDK Docker project. That's what the name I want to give, and dot means that from this current folder. So once I will execute this one, we need to pay attention that keep in mind that if that JDK version is already in the image, then it will use the cache version, and if not, then it will pull from that Docker. So in our case, because I removed that images from my local cache, so I'm able to execute this one in a way that is pulling that from the Docker Hub right now. So you can see that it pulled that JDK version from there, image open, downloaded newer image for OpenJDK8, and there is the copy happening, then there's a work directory setting, and there's are intermediate containers, and then you can see that javac command executed, and then removing intermediate containers, and then running. This is the command running in, this is the version number, and removing intermediate containers. So successfully build, and we can see that they are tagged our JDK Docker project image in the latest. So now if we want to see that images, so the command is docker images, and here we got the JDK Docker project, and the tag is latest because we did not provide it any specific version. If we want it to be, we can provide a very specific version, and we will need that once we will in the other, probably in other sessions when we are working with the multiple containers and see a continuous integration, continuous deployment, properly using Travis AI, and so on and so forth. So we'll need those ones because there are so many concepts about how you build that, how the different all those in that ecosystem, how other system knows that this is the latest version and whatnot kind of thing. So but for our running simple example, we'll skip that part in this session, but yeah, as promised, we'll discuss that in another session. So this is the OpenJDK, and this is the version 8, and this is the beauty of that, because they have many versions available for OpenJDK8. I'm pretty sure 7, 8, 12, you name it, and they have it kind of versioning over there. So I also have some older version you can see from the other NGINX, Redis, Postgres. If I want to use any of those ones, then yeah, they will be cached. They are already cached. Or let's run that command again. Now I try to build that again, and you see, boom, it's already done, because now this time the Docker realized that OpenJDK is already in cache, so it's picked it up, and it did everything, and it was milliseconds. So now we have the image, and we can run that one. Now let's try to run that one. We have given the name, so we know the name, so it's much more easy to run that one. So docker run -it rm name JDK and docker proj, and again JDK docker proj. So this is a command to run that program, and our expectations are that we should be able to see the output which was mentioned over here in that job program. So basically because there are only two outputs, one is over here and one is over here, so our expectations is that first from this while loop, this output iterator value 0 to 9 will be on the screen, and then based on this one for each, there will be consumer implementation value 0 to 9 on the screen. So let's go back and try to run this. and here we go. So now iterator 0 to 9 and consumer implementation value 0 to 9. So that basically concluded and a quick recap is what we did. We got the JDK version 8. We set some environments, we copied some stuff, and then we compiled our code, and then we ran our code. So in this, in this session. So what's the benefit and why are we doing that? Like that sounds like a lot for just running a simple Java program. Now pay attention to this, how this will evolve into a bigger picture. So let's assume that you have a big monolithic application, and also assume that you are actually using, this is your development machine and you are using that one. Now if I execute this command java minus version, so we see that I have installed Java 12. That's mean that if I have to use any other version of Java, it will be pretty hard for me to do that because I'm basically using Java 12. So I need to do a lot of workarounds to have that running. So now this is our Mac machine. It has JDK12. That's the fact. And then what we did is we put a container which has JDK8, and let's say this is our service 1, which is product summary, and that's using the JDK. There is a team, let's say there are 3 developers who work very hard and they support this thing. Oh, I can't send it back. Anyways, what I'm trying to do is, okay, that's probably better. Yeah, so okay. So all of those 3 developers, they are supporting this product summary service, which is developed in JDK8, and then there is another service which is service 2, and this is about let's say Black Friday sale service, and this is developed in JDK7, and there are 3 developers who are, oh, that's much easier, who are supporting this. Okay, yeah, that's better. Okay, who are supporting this service too, which is Black Friday sale service, and that's developing JDK7. Now the beauty of this containerizing your application will give you the benefit of doing microservices and decoupling your application in from a big monolithic application into microservices, and you can, for example, this Black Friday sale, on a very special day, you need couple of services running there. and maybe you just need to run 2 of those product summary services on a very specific day for Black Friday deals when those deals are on. And on the once Black Friday is over, you might not want to run those services at all, but then because there was a lot of sales, so now back office is working hard to ship all those orders, so they are using this one. So next day you need 4 of those services over there. So number one, the developers can actually create those services, and then they can spin more, based on what their role is in the team. They can spin more services, more containers, using Kubernetes pods concept, but we will talk about those a little bit in detail. So yeah, basically this very basic concept can evolve into a bigger picture, and then you can understand all the benefits of using Docker. So Docker make your life much easier as a developer, but this is not just about running a JDK and a simple program. In next sessions we'll talk about those into much details, so please stay tuned and subscribe to our channel. Thank you and catch you later. Bye.